So in this video, I will talk about my project demo. I will show you how it works, and I will explain the purpose of the project as well as the components and also how it will be operated. So first of all, I designed this project in order to create a simple timer which can detect when we wash our hands and calculate the proper time to kill most of the germs. Then we can wash the soap off. This project is designed because of the spread of the COVID-19. So by washing our hand properly, we can clean up and protect ourselves from the virus. So in this project, uh, I use a particle argon, Raspberry Pi, uh, and a bunch of LED, which is from red one, two yellow one, and one blue LED. I also use a SC SC HCSR04 ultrasonic model distant measure sensors, and as you can see is connected by many jump wires and the breadboard. And in this project I also include the software called IFTTT in order to send the notification to my email. uh, Now I will explain how all of them device connected. uh, First, I will focus to the argon first, and as you can see here, I have connected 4 LEDs, and this connect to 4 pins from D3 to D6, and the the sensors is connected to argon too. This ground pin is connected to the positive bus here. God is share the ground pin, and the VCC is connected to the VUSB, and the echo pins and the trigger pin is connected to D8 and D7, and to connect the Raspberry Pi to the argon, I connect the Raspberry Pi SDR to the argon SDR, and the Raspberry Pi SLA to the argon SLA, and so in here the two last one. And I also connect the Raspberry Pi ground pin to the breadboard. Positive bus is here, and that's how my all of my components connected to each other. I will provide a picture of the circuit breadboard in my documents later in the project artifact task. So now I will explain the code. First thing in the code file, I include the sensor library and the Y library, which is the built-in library for using the I2C bus. And I also define the constant for the range of the motion, and the input and output part we use for the trigger, and echo pin we use for the sensor. So this one is the state of our timer, and this one is the function rangefinder to record rangefinder for the sensor. And in the setup, we join the R2C bus as a slave by providing an address to the right begin. And as this is the only I2C slave device in my project, so I could use any address. Therefore, this one I use 0x08 address. And in the next step, I define the LED output and also define the sensor output and input too. Next, I use the on request event to call function called send data. Whenever the data is on request from the Raspberry Pi, then the Argon will send the data in send data function to the Raspberry Pi. And in the loop function, I assign the CM variable to the distance of the motion in here. And so publish is on the particle cloud to see the value of it. And the condition to start the timer is when the the motion range value is lower than 15 centimeters, then the LED timer is called. And I also always check the hand squat time status in order to publish the status, uh, the timer status to the particle cloud in order to make the TTT send notification to my emails, and here is how we send it. So whenever the Argon published a time event, and then it send me an email at my email here. And next one is a LED timer. So first up, when it is called, the state of the timer change to start, and also the LED, the red LED is turned on for 3 seconds. So at this time you can put a software on your hand. And next one, it will turn another LED one by one in a 20-second period. And after that, it will shut down and the state will change to 0 here. And finally, in the send data, this one is to send the timer state to the Raspberry Pi. So now I will explain the code I use in Raspberry Pi. And first, as you can see, the program start by import the SM bus library, which is stand for System Management Bus Library, and it is a library used for the R-square communication. The variables are created to represent the I2C address. That's it here, and the next one we go to the main. So first, because in this project I only want to receive the state of the timers, which is whenever it is called, whenever it start and whenever it ends. So I will only use read by function in here to receive the data from Argon, and then I will print out the response from Argon to my display. And this is executed in a while loop. So when the response is 1, which means the timer is started, I can create a count out timer, and after the timer is over, and then I print the congratulation text. And after that, if I want to shut down the system, then I will use the keyboard interruption. Now I will show you how my program will be run. So first, execute the Python code. So as you can see here on the display, the The argon answer to the Raspberry Pi is 0, which indicates that the state of the red timer is not started yet. So now I will try to make the motion in front of the sensor. So as you can see, the red LED is turned on, and the argon answer to Raspberry also turned to 1, and the cow timer is start. And as you can see here, the LED timer also started, and after 20 seconds it will turn off. Then I will try to make that again. The red light start first, and each of them start after. Now I will show you how it will be displayed on the Raspberry Pi. So now I will try to start a timer. And then it shows a congratulation text. If I have more time, I can create an app, or I will link it to a web page. But I don't have much time in this semester, so now try to start it again to check the notification I have sent to the emails. This one, let's start counting down, and why in the email here they're sending me. You see here. So that's how my project work. Thank you for watching.